Hi everyone. Today I wanted to go through the three gas laws that are associated with the respiratory system. These three laws are quite important in the function of the respiratory system as they essentially allow for the dictation of these functions. The three laws that I'll be covering today are Dalton's law, Henry's law, and Boyle's law. Let's first start off with Dalton's law. Dalton's law simply states that the individual gases in a mixture exert pressure proportional to their abundance. Let's firstly unpack what this statement means. Say we have a particular mixture, and let's take the atmosphere for example, in which nitrogen gas is present in an abundance of 70%, oxygen gas is present in an abundance of 20%, and let's say, for example, the mixture of all other gases, which I'll denote simply by M, is present in 10%. This in total equals 100%, which is the total composition of the atmosphere. Now, if we take oxygen for example, its relative abundance is 20%, meaning that 20% of the total volume of the gas is oxygen. However, this has a relationship with pressure as well, because say for example that the total pressure of atmospheric gases in total is 700 millimeters of mercury. Now, if oxygen is present in 20% of the total volume of the gas, essentially its pressure will be 20% of 700, which is 140 millimeters of mercury. This is denoted as the partial pressure of oxygen. And essentially, the partial pressure is denoted simply in chemical formulas as P with the appropriate gas as a subscript, which is in this case O2. The combinations of the different partial pressures of each individual gas in this mixture is what will give the total atmospheric pressure, or the total pressure in any environment. Henry's law, on the other hand, is a law that dictates that the diffusion of gases is dependent on not only the solubility of the gases, but the pressure and temperature. So, for example, say if we have carbon dioxide gas, the ability of this gas to dissolve into blood plasma, for example, which is clearly seen in the respiratory system, is dependent on the ability of the gas to diffuse into the blood plasma. It's dependent on the solubility of the gas, meaning how well the gas is able to essentially dissolve into the liquid. And also the temperature of the liquid. This essentially means that if the blood temperature is higher, then CO2 will be able to diffuse into the liquid as to a lesser extent. If the temperature is lower, CO2 will be able to diffuse to a greater extent. This is also related to Dalton's law in that the amount of gas in a solution is directly proportional to the partial pressure. Finally, Boyle's law is also quite important in terms of the respiratory system. It is defined by the formula P equals 1 on V, where P is pressure and V is volume. It defines that pressure has an inverse relationship with volume, as V is on the denominator. This is dependent on volume changes in the respiratory system in the thorax, and gases therefore always move and flow to equalize the pressure. Let's take an example. When we breathe in, if I crudely draw a person here, air comes in through the mouth into the lungs, and the reason why it comes in is that when we breathe in, we expand the lungs. This, according to Boyle's law, means that the volume increases. If you're with me so far, this means that the pressure will decrease, because if this denominator value increases, 1 on any value that gets bigger is smaller. So that means that as air always moves from an area of higher pressure to lower pressure, we'll be able to move from the atmosphere into the body. The opposite occurs when we breathe out. As volume now decreases, this means that this value gets larger. Therefore, as pressure inside the lungs is larger because of the lungs becoming smaller now, air is able to move out of the body. So these three laws are what define the respiratory system. Dalton's law, relating to partial pressures; Henry's law, relating to the solubility of gases; and Boyle's law, relating to the movement of gases.